Today we're going to be going over electricity within a circuit. So in this part 1 video, what are we going to learn about? So we're first going to learn about what is electrical current. Second, we're going to learn about what an amp is. Third, we're going to learn about how to measure current. Fourth, we're going to learn about what is a coulomb. And finally, fifth, we're going to go over some examples. So in this part 1 video, we're just going to mostly talk about current. In our second video, we're going to talk about what voltage is. And finally, in our part 3 video, we're going to learn about resistance. So let's get started with our part 1 video. So first of all, electricity in action. So in today's world, life will be impossible without electricity. So most electronics, everything from refrigerators to computers, requires current. For example, a plane needs electricity to run, our TVs need electricity to run, our fridges need it, and computers and mostly everything needs electricity. So basically today, without electricity, our life would almost be impossible to live. So now what is electrical current? So electric current is the amount of charge that passes a point in a conducting wire every single second. And most electronics, everything from a refrigerator to computers, requires current. And this is how a normal circuit looks like. So we're going to cover more about this later on. So that's just a little brief description of what electric current is. So now let's consider an example of a copper wire. So this is going to be our copper wire here, and we can see that there's copper atoms flowing inside of the copper wire. And the outer shell electron of one atom pushes the other and creates a flow of charge that is called electrical current. So basically what's happening in this figure here is that you can see that this is first a copper wire, and what happens is that copper is it has one valence electron on its outer shell, and if you remember from chemistry, if you have one valence electron, then you always want to lose it and give it away to another person. So what happens is that since it has one electron, this copper atom here is going to throw this electron and push it against this one. And the same thing this one's going to do is going to push his against this, and it's going to keep on pushing their valence electron on the outside. And with that pushing, it creates a flow of charge, and that is what we call electric current. So this is just an example of a copper wire. And now we're going to take a chain analogy. So this is back to our example of the copper wire once again. And this time we're going to look at an example that can help us understand more. So this is just going to be our normal tube that we have that is bent like this. And inside we're going to have marbles in there. So we're just going to line these marbles up like this. So right now we're just going to have 5 marbles just like this. So right now the tube would be full. We're not going to be able to fit any more in there. So what would happen if we put one more in there? So if we put one more in there, then what's going to happen is that this one would get pushed out. So when this one comes down, this one over here would get pushed out. So the same thing with this, as soon as one of the electrons pushes this one, then it keeps on moving. So this is just a little analogy that we can use to help us understand this more. And this is the same circuit again. So now we're going to go over current measurements. So this is our circuit again. So the symbol for current is the letter I. And electrical current is measured in amps or milliamps, so A or MA. And 1 amp is equal to 1 coulomb per second. So if we look over here in our diagram here, so what is 1 coulomb first? We're going to talk a little bit more about this later on, but I'll just give a brief understanding of it. So 1 coulomb is basically how many electrons flow per second. So we're going to look more about that in a little bit here, where C is called coulombs and S is equal to seconds and A is equal to amps. So we're going to look a little more about this coming in the coming slides. So now what is 1 coulomb? So to understand the circuits, we can also use what is a coulomb. So back to our circuit diagram. So 1 coulomb is equal to the charge on 6.241 times 10 to the power of 18 electrons or protons. And once again, we have 1 amp is equal to 1 coulomb per second. So 1 coulomb is equal to the amount of charge from a current of 1 amp following for 1 second. So basically, if any given point in the circuit, 1 coulomb would be equal to the amount of charge that is passing per second. And that 1 coulomb is also represented as 1 amp, you could say. So that is what 1 coulomb is and what 1 amp is. And now we're just going to go over some examples. So let's first look at a radio. So a radio consumes the current of 0.4 amps. So if we remember, if we go back to our coulombs, so the amount of coulombs that this radio would be using would be 0.4 coulombs per second. And then this is a light bulb. So a 100-watt light bulb consumes the current of 0.8 amps, which means it would be 0.8 coulombs per second. And finally, we have this microwave here. So a microwave consumes a current of 11.7 amps, or 11.7 coulombs per second. So these are just some examples to give us a better understanding of what device use how many amps. Now let's go over how to measure current. So an instrument used to measure very weak electric current is called a galvanometer, and this is how it looks like. And larger currents are measured with an ammeter or a milliammeter, and this is how that looks like. So those are just two different devices that you can use to measure current. And that's also basically it for this video. So thank you so much for watching. If you try to be useful, and we'll see you guys in our part 2 video.